Welcome. In this lecture, I want to give the formal definition of a relation. So we're going to suppose that we have a set A. So suppose A is a set. Okay. Then by definition, a relation on A. So a relation, and then this is on A. So that's kind of important, the set A. So a relation on A is going to be, so it's just going to be a set. So there's going to be a set R that's a subset of the Cartesian product of A with itself. So this is, I've been writing two copies of A. Okay, so these are the same set A. So I'm looking at a subset of the Cartesian product, meaning some of the elements of the Cartesian product. Okay, so this is kind of the first part of the definition. But there's a little bit more that we're going to need there. Okay, so if I'm going to have, so for A and B contained in my set A. So notice these two are elements of A, not of the Cartesian product. Okay, for these, we're going to have that A is related to B. Oops, I gave it the wrong color. A, there we go. No, we're going to make that clear because the color is important here. So A is related to B. Okay, and that's going to be denoted. So denoted. So we're going to write that as A is related to B. Like this. Okay, so this has the same meaning as A is related to B. Okay, when we have, so if and only if, remember I like to use this for definitions because this really is an if and only if statement. Okay, we have that this, so we have that this ordered pair, A, B, is contained in this R, okay? Okay, so let's just kind of, oops, that's a wrong containment. Let's just fix that. Okay. So this is another part of the definition. Okay, so these are two different definitions. So let's just kind of talk a little bit about what's going on. In the first one, right, we're deciding, what it means for A to be related to B, and it's going to be that, right, we're like capturing that information and having, the pair AB be inside of this Cartesian product. Okay, so this is an element of the Cartesian product. These are elements of A. And so this is just kind of shorthand notation. This is used more frequently, so it's good to get to know this. These two are elements of A. This is contained in the Cartesian product. And by saying what subset of A cross A, or the Cartesian product we're talking about, we're saying which elements are related to which. And for now, the order actually really matters on that. Okay, so let's kind of write this in, which is that by picking out a subset of the Cartesian product, we're saying which elements of A are related. Precisely, A is related to B when A comma B is in the Cartesian product. Okay, so that's this formal definition, but it's going to be very useful, particularly when we jump into equivalence relations. Okay, so I hope that made some sense, and I will see you in the next lecture.